Okay.
Good afternoon. Thank you for sticking around. I hope you have had an enjoyable and productive day. My name is Justin McKeag. This is Christy Harrigan. We're going to be talking about master data management today in MarkLogic. Christy will talk you through what master data management and why it's important, and I'll talk you through some of the examples. So first of all, my name is Justin McKeag. I'm a product manager. I'm based in our headquarters in California. I've been with MarkLogic for almost 9 years now, which is a veritable eon in Silicon Valley. I've got a background in consulting, mostly around application integration, and I've focused within the products team. I focused on a lot of the integrations, the data integrations with APIs, and the developer front end for MarkLogic.
And my name's Christy Harrigan. I am somewhat newer to MarkLogic. I've been here 18 months, but I have 8 years experience in the data management space. I actually started my career as a software engineer, working on MDM products. And then I've done some pre-sale, software architecting, and so on, before ending up here at MarkLogic doing a pre-sales role. That's my address, and I guess my GitHub was left off. But I do have a GitHub repository if any of you are interested. So today we're going to cover what master data management is. Before I start, who here knows what master data management is? Okay, so most people, but not everyone. So that's good. So it won't be too detailed for those of you who know, but we'll just cover off enough to understand basically what the current challenges are, what the current approaches are to mastering master data management, what some of those challenges are, and of course why MarkLogic helps to address those. And then we'll hand over to Justin again, who will look at, as he mentioned, techniques, use cases. And then finally, we'll have a session for Q&A. We are between you and cocktails, so let's get this going. What is master data management? It is the management of master data. Okay, what is master data? Master data is the core data that runs your business. It is your customer data. It is your product data, your location data, account data, and so on. And when you think about this data, this really is the heart of your business. Okay, this is what your key decisions are based off. And yet this data is probably, well, almost certainly split across a number of different systems. If we think about customer data, you might have a CRM. You might have some account management system. Your marketing department probably has its own systems. Perhaps you've got an ERP system which looks at master data, customer data. And if you've done mergers and acquisitions, you've probably got duplicates of this. So for very large organizations, we can typically have hundreds or thousands of different systems that all reference customer data. And so you have to first of all understand, what are your key customers? Who is Christy Harrigan? Where does she sit? What products has she bought? Where does she live? Who is she related to? Is she a high-value customer? And you need to understand the security around that. Who of you, I guess we're all EU citizens? Yes? Yeah, okay. So there's a new EU regulation come into play, the EU General Data Protection Regulation, which controls who can access what customer data, EU citizen data, where it can go, what it can be used, and so on. So how are you going to understand, when all of this data is disparate and sat in different silos, what the security of it is, what the retention policies are, and so on? So master data management then is how bringing all of this together and being able to manage that, get your arms around it, have a consistent single version of the truth, an authoritative source of who your customers are, what products they've bought, and so on. So as an example, we can imagine then that the elements of this one entity, the Christy Harrigan entity, we can have, for example, an address in one system, a credit score in a different system, the orders in a different system, and so on. But here's the thing. Most of these systems are relational, right? Most of us have most of our core systems built on relational technologies. And relational data strips the context from the data. So imagine like an SAP system. There's going to be 70,000 tables, each of which has bizarre column names that none of us are going to understand. Okay, fine, there's probably business services that help expose some of that. But when we come to actually extract that data so we can standardize it, we can get our hands around it, when we look at the actual raw data, we realize that it's split into these different columns. The context of the data isn't inherent. It isn't obvious when we go and look at these tables how that data sits together. And when we then try to bring this data together, we realize that the way this data is being pulled apart into different columns and tables probably looks different from one system to the other. So take my name, for example, Christy Harrigan. There may be one system where I've got 2 columns, first name, last name. I might have another system where I've just got a name field. So this data is going to look very different. And it isn't obvious by just going into these columns how that data fits together. So really, this is a really large challenge to master data. And when we're trying to bring it together, we have to overcome this inherent problem that we can't get rid of. OK, fine. So that's what master data is. Master data management solutions have been on the market for a couple of decades. What are some of the key approaches that are currently undertaken? There's a few, but we're going to boil it down to 2 for simplicity's sake. The first one is what we might call a registry approach. The idea here is that rather than trying to take all this data and bring it together in one place, we just leave it where it is. And what we do is instead, when we're trying to identify where this Christy Harrigan entity sits, we have a registry, if you like, that sits in the middle that keeps a record of where the various rows for each table are and how they sit together. So the advantage of this approach here is that it's very lightweight. I haven't had to do anything to my operational systems. All I've had to do is insert a new system in its place, and it creates pointers out to each of the systems that tell you how all of this data fits together. In essence, how all that relational data is structured into a single entity. However, what happens when we have 2 addresses in 2 different systems? I may have moved. So take an example of a phone company. They may have broadband and they may have phone. And I might have done business with them, for example, 5 years ago when I lived in a different address than I currently do now. And I may have phoned up the broadband department. Perhaps the broadband department was a separate company at the time. And they have one address. I didn't bother to tell them my new address because, hey, whatever, I closed the account down. I move and I go over to my phone company. I set up a new account with them with the new address. We now have two different versions of the truth. So how do we understand which of those versions of the truth is? Let's say we're able to identify what that is. You phone me up and you ask me what my address is. What are you going to do? Are you going to go and update the data over here? Well, that sounds simple in principle, but that's probably owned by someone. Maybe the system's an external system. If it's like a cloud software, the data's owned by a different department. So actually going through the process of updating the data, keeping it consistent across these different systems, can actually be quite a nightmare politically, organizationally. So this approach is good. It allows you to get going very quickly to identify where the entities are, but it's a little bit difficult to actually manage that data over time. And that's what we're interested in, right? Master data management. It also means that we aren't able to put our arms around things like governance and security and data quality. Like I said, there's one thing I might update an address over here, but how do I know that that update it can be applied over here? I might have security rules that are very stringent over here that aren't so stringent over there. Perhaps that system sits in a different country and that's now breaking EU regulation laws. Things can start to get quite tricky when we actually start to manage the data. So the alternative approach is the so-called hub approach. This is where we actually have an authoritative source of master data. We go out to all the source systems, we load the data in, and it's in this central place that we do the consolidation of the data. We understand what the correct address is, what the standardized model of name and address and account history and so on is, and then we have a single place. If we have inconsistent data, we can go through a stewardship workflow to make sure that we end up with the right version, and so on. It allows us to have transactional and security control around it, and if we aren't able to decommission the source systems, we can then perhaps start to put in pushes, bidirectional updates from the authoritative system back to the source systems. However, this is really quite a heavyweight approach. In many ways, it's where you want to end up. But again, you've got to go to each of the source systems. You have to do modeling and understanding, subject matter experts for each source system. You have to pull it together. And now what you're doing is you're coming up with a single enterprise-wide domain model for what a customer is. Well, I challenge you. Go to your organization, go to all the departments where they hold customer data, and get the head of those departments to agree on what a customer is from a data model perspective. Heck, even from any perspective. You'll find it's really quite hard to do. So when we look at what these master data management solutions look like under the covers, we realize that even if we put aside all the political challenges of getting all this data into a single model, there's a lot of moving parts. So we've got to take the data, we've got to extract it, typically put it into staging systems where we can start to do some analysis, some pre-cleansing, some matching, and so on. We then consolidate that into our consistent domain model. We might then enrich it with reference data, metadata, governance, policy data, information, and so on. Of course, all of this process is going to have exceptions that come out at the end. You know, 2 addresses don't match. Well, what do? We need to kick off a manual process to reach out to the customer to find out what the correct address is. So you put that to another system, kick off a separate workflow. And actually, you end up with quite a conglomerate. So, you know, you go out to MDM vendors and they say, we have a customer solution for you. But it's not it's not a point solution that you just put into place. It's actually quite complicated. It requires a lot of integration. And it's going to involve ETL technologies, relational database technologies, application servers, federated search, the works. When you're trying to come up with an integrated, highly available system with consistent security, consistent transactions, yes, MDM vendors will have done a lot of this integration work for you, but there's still typically a lot of work that goes on to actually make these work for your enterprise, because each enterprise is distinct. So let's just quickly review what some of the shortcomings are. I've mentioned 1 or 2 here now, but really the big one from at least a MarkLogic perspective, the one that we're going to look at, is the fact that you need a consistent model, right? Because relational technologies need a relational model, right? You have to have decided what your schema is. What is the unified schema of customer? Once you've agreed on that, if you can possibly agree on that, and there are, well, industry domain models for doing that, but it still becomes a political challenge to understand which system becomes the authoritative source for which attribute, how's that going to map, what does the ETL look like, what happens when one of those source system changes, what if that system is an external system you have no control over? It gets quite tricky. How do you know when you've gone through all these mappings, what the provenance is? You know, I'm sure some of you will have been to some of the regulatory talks where auditors are going to come in or a customer comes in, and you've got to understand how you arrived at that value. When we look at this previous diagram of all these steps, how does that data flow together to arrive at the end system, end value, and how can you get back to the source values in case you made a mistake or you need to show you're working? And we haven't even begun to talk about unstructured data, right? Like MDM systems are predominantly relational. They're really not terribly well suited for this huge world of unstructured data that I'm sure you've probably heard from many keynotes already. So what does this mean, practically speaking? Average MDM projects take between 3 to 5 years to see an ROI. And I can't remember the statistics, so I don't want to lie to you, but it was a non-insignificant statistic that a number of them fail. They become too expensive, too unwieldy, and the CFO or the CIO or whoever says this is becoming too much of a cost and the benefit isn't there. They aren't really able to keep up with the fast-paced change of the business because you have to have this fixed domain model. And because every time there's a change in one of the source systems, you have to remap what that data looks like. And because you're probably going to struggle to agree on get each unit to agree, sign off that model, and agree who's going to be the authoritative source for which attribute, you end up fighting, having infights. The ETL is expensive, it's brittle, and it's really hard to have this full end-to-end lineage. And so the result is there's just too many moving parts. Okay, so clearly MDM is a good thing. Clearly we want to get our arms around our master data. It gives us a competitive edge. It allows us to know who our customers are. And clearly, whilst there are some very mature and very capable MDM solutions on the market, there are some challenges. So we need a new approach, right? What we need is we need the ability to have a flexible data model, one that is able to keep up with the dynamic change of the business. If we bring on a new system, or we go for an acquisition and a merger, or one of the source systems wants to change what a customer looks like over here, we need to be able to handle that. I don't want to have to go through another 6 months of ETL project just to update 1 or 2 columns. Okay, that's just not tenable. We need to be able to bring all this data together, and if we're not having a consistent model to which everything gets mapped to, well, don't we still have the same problem of stitching together what an entity looks like? Absolutely. We haven't necessarily taken the problem away by having a flexible model. We just need a new approach on how we build those entities up. We need something that is much smarter in picking out the data from all of the different systems, identifying what it is, and being able to apply flexible rules as to how we pull that data together. In other words, we need to be able to index all of our data, all of the structure, every time it comes in, independent of how often it changes. And we want to be able to have consistent governance. We want to be able to track how that data has flowed through the system. And we want integrated security, transactionality, high availability, and everything else. OK, so the first difference in how we think about MDM in a new world is we stop thinking about tables, rows, and columns. We haven't solved the problem by mapping things to a relational domain model. We've just gone from 50 disparate systems with no context to one absurdly gigantic model with no context. Instead, we want to think about data in its natural form. We want to think about the customer entity. So sure, we're going to get data from the CRM. Sure, we're going to get order history from the ERP system. But we want to be able to pull that together into a single entity. You might call it a document, unsurprisingly. You want to be able to keep that data as it is from the source systems, but you want to be able to understand how pull that together into a single entity. You then want to be able to update all of those entities transactionally. So let me give you an example. Say we've got an address from a CRM system and we've got an address from a marketing system, and the two don't agree. Well, we might need to go through an external process, probably an expensive one, to reach out to the customer and figure out what her address is. But in the meantime, we just have 2 versions of the address. As we develop new applications against this system, if the marketing department wants a marketing application and they want to use their version of the truth, they can do, because the source data is still there. The CRM data can use their version, or we can agree which data, or for new applications, we can agree which one wants which. But for example, if there is consistent data across the 2 entities, we can ensure that both is updated inside the same transaction. We can version this data, so that over time, then if we manage to get, say, the marketing department to agree their version was out of date, we can push that new version through, and we can timestamp when we did that. So we can still go back in time and understand, hang on a second, our marketing campaign didn't work. Well, the reason being is because if we go back 6 months, we hadn't finished our external process to get the correct addresses. They were using wrong addresses, and we can see that because we haven't gone and overwritten all of our history. It's there in plain sight. okay, it wasn't that the marketing department failed, it was because they were using old data. Hey, why don't we target some of the customers we now know the addresses were wrong and have a more targeted re-effort? Perhaps we'll start to see some better results. And of course, because this is just flexible data model and an envelope pattern, perhaps some of you will have heard that in data modeling workshops or so on, we can just tag our metadata. We can say, well, this came from the CRM system, this came from the marketing system, and the marketing folks want to use this version of the truth. So when we surface this data out to the application, if the request is coming from a marketing application, make sure you surface this version. Do you see how we've moved away from the need to have one universal, one rule, one ring to rule them all, one domain model to rule them all? It's okay to have different versions of what a customer looks like. And when we do start to consolidate towards a consistent domain model, because it's not a bad thing to have agreement, and we probably will over time get a level of agreement. And so we do start to move new versions of what a customer entity looks like. We can have transformation rules that move from old to new. And because we can persist the transformation rules, we're able to understand exactly how we moved from entity to entity to entity back in time. We haven't lost all that rich information. We're able to understand why a certain thing happened, what an address was at a certain point in time, what it looks like now. We've got all that rich information, and we're able to do it iteratively. So we haven't had to agree all of this up front, and then, holy crap, we made a mistake, quick, change everything. Want to change something, that's fine. I make a change here, have a little transformation rule, update. Becomes much more agile. So what about the actual underlying complexity of the solution? Remember we said this was also a problem. There's lots of moving parts. Well, MarkLogic is a database. It's an application server. It's a search engine. You've got one platform. It's got high availability built in. It's got disaster recovery built in, transactionality. All right. Things don't work quite like that in the real world. In reality, what we probably find is you start off here. You would put a MarkLogic solution, and it would probably play a relatively modest part in your solution. You're still going to have your ETL functions that you've written. You don't want to throw those. Probably got some matching functions down here you want to written. You probably still got some services that serve applications over here. Use those. MarkLogic encourages iterative development. Put MarkLogic in a place, start chucking in some data from different systems, start iterating towards what a consistent domain model might look like, iterating services around that, and over time, make that grow, make that a bigger part of the solution, start to decommission, as it makes sense, the legacy solutions. So, that was master data, why it's important, what some of the challenges are, and how we might be able to overcome some of those. I'm going to hand over to Justin to talk about how we actually do this in practice.
Thank you, Christy. Oops, that's the wrong way. I'll flip it around. There we go. OK. So we have many customers that are doing master data management today with MarkLogic. They probably wouldn't identify it as MDM. And we probably didn't know it was MDM when we were starting projects with them. But what it's turned out is these customers are running their businesses, their mission-critical businesses on MarkLogic, and managing their data in the way that Christy just described. So I'll talk about 4 of them here. I think it was Gary this morning that had mentioned Aetna, and I've been doing a lot of work directly with them. They're a very interesting company in that they've grown by acquisition. And so, of course, when you're growing by acquisition, you're going to inherit the systems of the acquired companies. And eventually, you want to be able to have that 360-degree view of the key entities in your organization without having to inquire into each of those individual systems. So that's incredibly risky, and one of the major reasons why M&A does not work, why it doesn't pan out, because you're unable to, 1, politically, or 2, technically, integrate those common attributes. And so one of the projects that we're working on takes 200 source systems that describe internal employees. And HR had no view of all of their employees. So when they had to terminate somebody or when they had to onboard a new employee, there was a whole mess of systems and workflows that were very expensive and very time-consuming and imposed a serious legal risk. And so what they were able to do with MarkLogic was to consolidate those systems into one MarkLogic system, model their employees as they went along. So as they worked through some of those hard governance and political issues about defining what the data is and where it came from, they understood the system better. And they were able to iterate on that, and the actual end product turned out faster and better because they were able to get incremental results. The U.S. Combatant Command is a part of the U.S. military. And with the U.S. Combatant Command, they do a lot of information sharing on the ground. So literally, MarkLogic is deployed into backpacks in Afghanistan and onto Humvees. And what I find interesting in that is that data quality is a flag for that. Data quality is actually a high-level, valuable piece of information. So if you get a report of a bad guy in the field that has 2 names, that's not a quality issue. That's actually a flag for the fact that he's probably trying to hide something. So they see all of this data that perhaps they'd never seen before, and being able to pull that in, save it as is without even understanding what it is, and then sync it back with Central Command later, and then have the human analysts work through that and define those events, those locations, those people, the master entities that they're managing in their mission. There's a top entertainment company. It's funny. I've been down to LA a couple times recently, working with entertainment companies, and they operate in fiefdoms. You can imagine the creative types wanting to maintain control over their domains. But what this does is it wreaks havoc for the IT people. So being able to share things like production budgets across an entire studio is a very complex problem. Think about all the entitlements they have to manage from a legal perspective. So these assets are their master data, and using MarkLogic, they're able to consolidate that into a way that they could get a view across the organization. Finally, healthcare.gov. This is one that comes up all the time. I'm not going to belabor it, but again, this was one of the largest data integration problems that there has ever been. And trying to get all 50 states and the federal government to agree on domain models up front was going to be impossible. So they weren't going to have any visible progress on this critical project until they were able to have that political and technical agreement. And that was just impossible. And so with MarkLogic, they were able to take that gradual approach. They were able to model and expose the data as that political and technical alignment came. So what I'm going to talk about are 4 techniques that we've seen as drivers to success in a lot of these MDM-style projects with MarkLogic. So the first one I'm going to talk about is the envelope pattern. So the data modeling can take up to 30% of a project's resources, and it's commonly cited as a key reason why a project may fail. You can imagine all of the politics, and not to mention the technical issues with data modeling and agreeing on terms and what the data is. So what Christy had described earlier was what we've commonly called the envelope pattern. And I'll revisit the diagram here. It's not rocket science, it really isn't. But it really illustrates the flexibility and the power of having that schema when you need it. So the important part is we can ingest those source systems. I'm showing some XML here, so you could imagine we've got the CRM system and the ERP system. We can ingest those source systems as is. We may not understand the data. It may be wrong. It may be terrible data. But being able to get it into a system where it's managed, where we can track its provenance, where we can check its governance, is an important aspect of the entire process. And then, as we see fit, as we need to, we can expose, we can harmonize that into that common model. And so we can store this all together. So the important part about this is that we're managing those together. So we've got a consolidated view of the security, a consolidated view of the provenance, a consolidated view of the governance. And then we expose, once we get agreement on those canonical entities, we expose only those attributes as we need them in the documents themselves. And those are managed along with the source data. So this is the schema as you need it. So it's not the fact that relational has a schema that's the problem. It's the fact that relational only has one schema all the time. Sometimes you want 0 schemas, sometimes you want many schemas. And things like the envelope pattern allow you to do this with data that you might not have anticipated. And at the other end of the spectrum, manage those canonical entities. So the next thing I'll talk about, and Christy touched on this a little bit earlier, is the notion of a common services layer. So as we talked about, this is the kind of the counterpoint to the envelope pattern. And this is about exposing those data services in the domain for the uses that they're being consumed downstream. So, for example, the fact that we have multiple addresses for a customer, as Christy had talked about earlier, is probably important to the marketing system. So the marketing department wants to be able to leverage that and contact this person in different ways. But the billing system that's using this data probably wants the one address where they can collect the money. So you might have the same underlying data with all of this messy complexity and those cleaned up canonical entities, but project those through different lenses through this common services layer. So as Christy had said earlier, MarkLogic includes an HTTP server. And the idea with an HTTP server in the database is not to replace WebSphere or Jetty or Spring or whatever. The idea is to provide REST services, REST data services. So being able to keep the application logic that is most that is the data logic, the governance of your data, be able to keep that in the database, be able to version that with the data itself, and expose that over HTTP, which anything can consume HTTP. And MarkLogic provides a full programming interface that allows you to build these very flexible services. So I can project that canonical customer for use in a customer system. I can project just the domain model. So I can do queries like, which of my entities have a billing address? What does that billing address mean? Who approved the definition of that billing address, and how has that changed over the life of this system? So being able to project these entities and their metadata through HTTP services built into the database and consumed by other application layers or other downstream systems. So I'll talk a little bit about semantics. Well, there's several other sessions in this during this week that will talk in much more detail about semantics. But really the key takeaway with this is that you want to manage all of the assertions about the data in the same place where you have that master data. So we can take a look at, I think David Gorbett this morning in the keynote had a presentation that had an example that looks something like this, and we're beating the customer and products over the head. But you can imagine other domains of these master entities. So with semantics, you can say things like this customer entity, encoded in a document, has agreed to a particular sales order, encoded in another document. The sales order has references a product. That product is of type a specific enumeration from this taxonomy of product types. The customer also files a support case. That support case may reference a product as well. And so these assertions are part of the data. So the agrees to, the has, the files, the about, these all have very specific definitions that are in the database. Those definitions can have assertions themselves. So Pete was the domain expert that defined what agrees to mean. He worked with the legal department to map it to the regulation in terms of the contracts. So again, all of this is part of that web of data that describes these master entities. And with semantics, you can put these in a way that's not just human readable, but also machine readable, so that you can write queries about them. So some interesting queries are the ability to inference over these relationships. So the fact that a customer agrees to a sales order and the sales order has a product means the customer purchased that product. The fact that the customer files a support case about a product means the customer that uses that product. So we haven't made these assertions explicitly, but what we've done is we've inferred them from the other assertions. And you could imagine, once you have this rich web of assertions, all of the types of inferencing that you could do to find relationships among your master entities. So the last thing I'll talk about here is decision accountability. So as Christy had said earlier, it's not just that you have a consistent and accurate view of your data, but it's that you can prove to your auditors, to your CFO, to the compliance, to external compliance, how you got to that data, how you made a decision using that data. So it's not just that you're sure that you have a consistent view of that data, but you can prove how that consistency and that accuracy came about. So the two aspects that I'll talk about with MarkLogic are bitemporal and tiered storage. And these work together like peaches and cream to provide a very solid compliance story. So the first one is bitemporal. So bitemporal is kind of hard to get your hands around, but just imagine it as a way to look back in time and get the perspective of a time in the past about what the database looked like. So we'll start on Monday. We've got our customer entity we've saved into the database. And on Tuesday, we update that customer entity with a credit score that came from an outside provider or whatever. And so based on that information, on Wednesday, we extend a new line of credit to that customer. So on Wednesday, we've made a decision to use that updated credit score and extend these favorable credit terms to that customer. But really, what happened later in the day what happened at first thing on Wednesday was that we realized that there was a problem with the feed that we got last night from the credit bureau. And really, that credit score should be lower, and we probably shouldn't have extended those favorable terms for that line of credit. But that error wasn't picked up until Thursday. So we recorded the fact that the credit score had changed on Wednesday after we had made the decision. So if you look at the perspective from Friday with perfect information, well, of course, why did you make that dumb decision to extend that line of credit when you knew that credit score had been downgraded? But what bitemporal allows you to do is say, from the perspective of Wednesday, what did we know about the data? So this is how you prove to your CFO why you made that line of credit decision. With a single time axis, you're not able to get to that point in the data. So again, having this all managed in the same place allows you to do these types of queries and have confidence in the consistency and accuracy of the data and how it got to the place where it is. So with bitemporal, you're saving versions of explicit versions of your data, and that's how bitemporal works. We have APIs that allow you to manage how data is versioned, and it will manage those two time axes, the valid time and the system time. Very detailed, but we can go into that later. But once you're saving all of these versions of your data, you want a way to manage them economically, so that the usage of the data is different from the current data. So for example, here I'm talking about a bank that needs to keep 120 days worth of current transactions active, and they're getting in about 200 gigabytes a day. So that comes out, the math works out to about 96 terabytes. But that needs to be very active. It needs to have low latency, and it needs to have high availability, and it needs to be on the most expensive hardware. But they also need to keep a larger window of multiple years of data. They only access that larger window, those 7 years maybe, at period ends. So maybe at year-end close or at quarter end. So it doesn't need the same latency requirements, and it doesn't need the same HA requirements. They'll spin it up, spin it down when they need it. But it needs to be online and accessible. And then they have the very long tail of historical data that they may keep around for back testing of models or for other statistical analysis. And this can be cold data. This can be on offline storage. But they want to be able to bring it up very, very, very quickly. And so you see the use case for this data. We're keeping all this history, this rich history of the data, but the uses are very, very different. And the economics are very important here. So if you look at what MarkLogic's tiered storage can do, is we can allot the correct infrastructure, the appropriate infrastructure for that hot data, the stuff that's being updated that needs that low latency, to the most expensive infrastructure. We can have separate infrastructure, so we could have SSDs, for example, as the medium for that active data. You can allot spinning disks, more densely packed for that warm data, where you need to be able to query it online, but the latency is not the big issue. Then you could have something like HDFS or S3 as the long tail. So by being able to tier these, you can align the infrastructure spending with how the data is being used, but still maintain all of the rich indexes and the security and the governance because the data is in MarkLogic. So if you look at the math of those, I'd be happy to go through the details of this with anybody that's interested. But if you look at the math, this is exactly how you want to have your costs aligned. So have that active data on the expensive hardware, have the compliance tier on that mid-range hardware, and have the analytic tier as low cost per unit. So we've gone through kind of a whirlwind of MDM with MarkLogic. Christy has talked about some of the use cases, why MDM is important, what master data management is. And I think the key takeaway is that you absolutely need a consistent and accurate view of the master data. And you need to be able to prove how you got to that view. But with today's technology, it's very difficult to get that upfront alignment both from a political and a technical perspective. So you need a system like MarkLogic that allows you to model and expose that data as is in the dimensions and the forms that the users are using. And this flexibility is key to understand, to be able to account for changing requirements, because requirements are always changing, and you need that flexibility to account for this. But you can't have this flexibility at the expense of governance. So it's absolutely critical for these mission-critical systems to be able to understand the provenance, the legacy, the lineage of how the data got there, and be able to ensure that and prove that. So I think we've got about 10 minutes for questions, and we'd be happy to stick around here or at the cocktail party. So does anybody have any questions? In the back there.
Oh, hi. So earlier in the presentation, you mentioned the problem of distributed updates to data and how they could become inconsistent.
Mm-hmm.
And I'm just wondering how that plays out in a solution that would include MarkLogic as a component. How do you ensure that system A and B still share the same concept of what a customer is?
Yeah, excuse me. It's a good question. And
can you summarize and repeat the question for the recording?
Oh, yes, certainly. So the question is, if we move to a hub architecture, traditionally or MarkLogic approach, and you're consolidating these entities into consistent models and or values, how do you ensure that the source systems, if you aren't offlining them, are kept consistent with this view? And the answer is, in some cases, you might be able to. So you might be able to have this bidirectional update. If, for example, it's a CRM system that's under your control, then you would make sure that, as Justin said, you've got different lenses. So you might apply a kind of CRM lens that every time you get updates to the central system, it just pushes that data back out in its raw form. Reality, though, you're probably going to have systems where perhaps you are offlining it, the accuracy of the data isn't necessarily as important, or you don't have so much control over the data. In those cases, and it has to be done on a case-by-case basis, it may be acceptable to allow that system to become out of date. In a certain sense, it's no better than what you already have at the moment. Fundamentally, a move to a dynamic model, a dynamic domain model away from a static one doesn't fundamentally address that problem. But what it does allow you to do is have the different versions of the truth and the different domain models, so that, for example, you can better address the updates of the different systems, right? You haven't lost the initial context of that source system by having multiple versions. So it's not a perfect answer, but it can help a little bit, for sure.
So if you make the full jump to having the centralized hub as the authoritative source, you might actually update that canonical entity. So you could imagine a service that allows updates to the customer entity here. And the fact that it's different than the source that you've also annotated in your document, that could be the source of a report, and then maybe that's exception handling. Maybe that's a batch process that goes back to those systems and says, here are the discrepancies we have from the upstream systems and the downstream systems. How do we figure these out?
Yes.
You talked to get that kind of hub thing to work, and if you want to use something like the envelope pattern, then you need to do the matching bit of it to get everything into the same document. You didn't really go into much detail about how you might do that bit. So some sort of pointers about how you might tackle that bit of the problem and where MarkLogic can help. But equally, if you're not able to do the matching up front, and actually you just, I presume that an alternative tactic is to just dump them into separate documents and do it as a later search or aggregation component. And when might you do either or, given that not everything has a primary key that you can link on easily?
Absolutely. It's a great question. So data matching is a subject onto its own. And the reality is that there is no silver bullet to matching of data. And MarkLogic doesn't fundamentally make that problem any easier. When you think about data matching, you might find that it's going to be per organization, right? So the golden rule of data matching and data consolidations is always driven by the data. So each data set or data sets will define its own requirements. So you might find in some cases it's relatively simple. You might be able to do fairly simplistic rules of, well, if the customer ID matches, then, you know, with a certain degree of confidence. In other cases, Harrigan, for example, is no one spells Harrigan, right? I guarantee you're all going to spell it wrong. And so, you know, in some systems, you know, they may have got it right because I'm sure that they spelt it right. In other systems, it was just tapped in, as it were. So how do you get those to match? Can you use phonetic type, you know, well, it sounds the same as, or is statistically, you know, fuzziness? That kind of logic you can write in MarkLogic. MarkLogic's search capabilities and semantics, again, provide nice accelerators to that. So, for example, you know, its ability to index data and do kind of closeness and so on helps you do that. And rules and semantics, you know, like as long as these two values and all these values match, then therefore it matches. Similarly, though, you may decide if you've got really, really, really messy data, perhaps going to an external tool or solution or partner to do that data matching for you might be suitable. A lot of customers will have built their own, maybe even inside SQL, you know, a SQL, you know, using similar sorts of things. So you can still leverage those if you've already developed that, or you want to use an external tool. But to your point, exactly, the first step is just dump it in. Perhaps you can do some simple first pass matching inside the database that gets you pretty close. And then maybe you either need to build complex rules inside or outside that goes through that iterative process. The key thing about data matching is you're always going to end up with three sets of data. Data that definitely doesn't match, right? Christy and Justin are not the same people. Christy Harrigan spelt with 2 R's and 1 R, because we've understood that that's a rule we want to apply. And we don't know. We don't know the confidence levels. It fits somewhere in between. And in that case, you need a human intervention, right? So, you know, again, there's probably workflow that gets associated to that, exception handling. You dump out that bucket, you hand it off to some poor data steward somewhere who has to go through and make a decision or reach out to the customer or so on. So, yeah. But it's a good question. Data matching is a hard problem. I mean, it's fundamentally, you know, intractably hard problem. So, yeah.
So, when you're talking about the envelope pattern, are you suggesting that if you're able to do that matching up front, then there are advantages to doing that matching and putting it all in one document in the envelope because of the ability to index it all? But if you're not, just stick it all in and deal with it later.
Exactly. And exactly. And so where you've got these three buckets, where you've got the bucket of match or not match, you can put that in the envelope and leave the rest to then be sorted. You know, so there's still value in having that source data there and maybe receiving updates from either the source system or from new applications, but you maybe can't, you know, like, so yeah, so if we talk about things like insurance, you know, where we've got this bucket of not sure, we might not want to offer them certain policies or do certain things to that messy data, and over time we refine it. But yeah, we can have that mix and match.
In terms of getting the documents, I often get the question about, well, should we do that transformation, that turning it into a document externally from MarkLogic, or should we do that in MarkLogic and all those joins and transformations and matching in there? And of course, the answer is it depends, because oftentimes you will have domain experts that are working in tools today. So somebody has defined the Hibernate rules that define a Java object that maps to your relational schema. That's great information. That is kind of a document view of that entity. You might already be publishing SOAP requests that define these entities in a document format. So there's probably views that in the SQL database that are used in the applications for form building and things like that. So there are entities and document-like things all around, and it's not necessarily just a raw dump of tuples into the database that you now have to weave together by hand. And if you need the help of your domain experts, which you absolutely will, weaving those together in hand in MarkLogic is going to be a lot more work than weaving those together in SQL. So I would encourage you to put the tools into the domain experts' hands that they're familiar with and are going to be capable with, and then move it to MarkLogic when it makes sense.
Any more questions? Oh, drinks coming.
Everyone's thirsty. Well, thank you very much, and enjoy the rest of the week.